Good afternoon, everyone. Hi. Hello. Just a few more people coming in. Okay. So welcome, everyone. Thank you for being here. I'm Vanessa Formicola. My pronouns are she and her. And today I'll be talking about TDD and other drugs, or in other ways, some of the ways in which us as software engineers tend to look at quality as something that we can solve, like a magic pill that solves your problems. So just in case you're of the scary type that is worried that I'll be blabbing for hours, this is a little bit of an agenda of what I'll be talking about. So I'll just give you a little bit of background on me and where the talk comes from. So especially on the key issues that I've encountered and what pushed me to talk about this topic. And then I'll introduce the concept of holistic quality, and then there'll be some conclusions, and I'll be happy to take questions at the end if you have any. So, a little bit of background. So I have a pretty conventional background, computer engineering degree, master's in software engineering, and then I became a software engineer, like many of you. I first worked for Relics in Read Business Information, was a publishing company. I then worked for Microsoft for quite a few years, and then I worked for ThoughtWorks for 5 years over 3 different countries, 11 different clients. First as a senior engineer, and then as a technical leader. And this will help you get some context. I now work as an engineering manager for Flow, which is a company whose purpose is to improve the life and well-being of women and girls all over the world. Apologies. Okay. So, again, a little bit of the experience. Again, this is to give you some context of where I've noticed some of those patterns. So over the years, I've worked on different domains. So whether it's fintech, whether it was health tech, whether it's communications, you name it, I probably gave it a try. And there, I've done multiple things. So whether it was different tech stacks, and you can see a few there, full stack development, worked with architecture with cloud, CI/CD, but I think what's particularly significant for the purpose of this presentation is that when I worked there, I've worked for a period of time as a software engineer, but also I alternated in the last years in doing things more towards identifying problems in teams. So I used to work as a consultant, software engineering delivery, but also consulting, meaning that I used to coach people in best practices, identify what were their biggest issues at, team level or up, the processes, the software, doing technical analysis, which is a bit of a different prospect than when I was, let's say, only coding all day, which I have done for a bit. So what did I notice? What I noticed was that actually similar problems happened everywhere. And it really had nothing to do with which technology you're using, kind of people you had there. It really, really happened over and over that I would have exactly the same conversations in completely different environments. So what are some of those issues? So clearly, these are just few. I'd be happy in different circumstances to maybe go through, some horror stories. But what's important is to look at the patterns of these and how these actually are not domain-specific or technology-specific. For example, insufficient testing is something that I have literally found everywhere. I've very, very rarely seen code bases that had enough tests to give a team the confidence they needed to be able to make any change at any time by any group of people. Low-quality test, even more. Even the best developers, the best code bases where you would see fantastic production code had really, really bad test code, because people tend to not put the same attention in their test code that they do in their production code. Same for unclear test definition. So it's a joke of mine that in every team I go, I will find different definitions for test, and often the name is the same, but they do completely different things. So usually I try and check, what's the difference between different teams, different organizations, different companies, even within the same team. Sometimes 2 people will give me different definitions for the same test. Another thing that happens that I've witnessed more than once is there is one broad term, and then there are 3, 4 types of tests in that category, which hence the confusion, right? Because everybody's doing their best. But there is confusion. And, among other things, is in general this disengaged attitude towards testing. Now, not many people these days would say completely they hate it, but there's a sense of kind of disengaged. It's just a little bit less important. Now, What I found is that usually there are two categories of software engineers, and I fall under the category with a little heart, unfortunately. So either there are people who simply can't live without their test. They love it, they pet it, there's no feature without their test. And there are people who tend to have this bored hostility, I call it. Nobody says, I hate, I don't want to do tests. But they kind of do the minimum possible. They do it at the end. They do it because somebody is really asking them to do it. It doesn't come with the same passion that they try and improve performance in the rest of the code. Really passionate, really great developers I'm talking about. So why is that? So the most common thing I find is that people are just confused. And it's not, again, not because they're not good, it's mostly because this feels like it's a branch of a discipline that people have kind of underestimated it somehow. So the conversations I always have is, what should I be testing? Why should I be testing it? When? So generally, there's a sense of confusion, in my opinion. So where does it lead us? So then that makes me wonder, right? Why would I care? So many people don't care. Why would I care? Or why would you care? So to me, this is my 2 cents on why we should care. First of all, I'd like a raise of hands for anyone who doesn't want their code to work as they expect it to. I mean, I know this was a bit of a joke, but fair enough. So, and then the other thing is, everybody is a product owner or within your team, right? You want to make sure that you can make changes quickly and often, whatever kind of change you want to do. I've never seen somebody who's comfortable with changes taking a month, right? So how do we achieve to make sure that our code does what we expect it to do and that our changes are in a reasonable amount of time and a reasonable amount of people? And in my journeys, I only have this answer, which is quite simple but challenging. So I believe that the only way to know whether your code will do what you expect it to do is add some automation tests, which kind of kills the questions of what should I be testing? And then from the other aspect is how can I make sure that my code is in such a way that I can make these changes quickly, flexibly, without issues? And the only answer I have for you is that it has to be a good quality code base. And by that, I mean all your code, not just your production code. So what does it lead us to? So this is the usual sentence, right? We've all heard it, quality is everybody's responsibility, and I believe in it. I would recommend it. Although what I feel that is when something is everybody's responsibility, things fall between the cracks. And it's not to underestimate the fact that we should all have, our quality hat on, but somebody needs to feel that that's their job to make sure to also keep everybody accountable. And to me, the one job role that is 100% responsible for the quality of the code base is the developer. And it is a developer because it's the only one who has in their job definition to write quality code. Considered to be the code expert within a group, product owner, surely will be the developer. So let's reflect on this a second and think of why. And I know this is trivial, so test code is code, but it is something that actually I think is underestimated. Because again, I've seen PRs, pair programming sessions where fantastic developers wrote production code that was really great and really, really bad test code. And it is because they weren't treating it with the same respect, because test code is just code. So let's move on to what can we do about it? Let's have a think through. So I'd like to approach this concept of holistic quality. So this is clearly just a Google search on the term holistic. And how it is described, and philosophy is described as something that can't be characterized without the sum of its parts. So you have to look at the system in a complete form. In medicine, it's even better expressed for our context. It's saying that when you address the disease of a person, you can't just look at the symptoms that they have. You have to also look at their social factors, their mental state, everything that is around them. You can't just look at the single symptom. So what I'm trying to say is I do believe that quality is not something that you can just compartmentalize. Add it to the end, add it to the beginning. It's something that is part of how you bake the cake. It's all together. And if you want to address it properly, you need to address all the software delivery factors from different angles. So this is a diagram of where I consider the 3 pillars to support holistic quality: architecture, code, and people. And I'll go into each of those to express, my thoughts in it. And I'll go a little bit deeper. So let's start with architecture. Architecture can be expressed in many ways. I've put there a definition that helps within the context of the exercises I've been doing. Clearly, this is not the only one, and there are others perfectly valid. This is within this context, that's how I address it. So we refer to architecture as all the components and their relationships that together allow you to deliver services to the client. And when I look at this, I look at the logic of the architecture, the technology that implements the architecture, but also the infrastructure, as 3 things that you can't really separate. So I started talking about, within teams, about the concept of quality threat modeling. Some of you might be familiar with the exercise of threat modeling for security. If you're not, it's usually an exercise, I'm sure people do it in different ways, but it's usually an exercise where given an architecture with a team and 1 or more security experts, you look at your architecture, you identify where there could be risks, and you decide mitigations that then usually get addressed. Now, I believe we can do similar things with our architecture, expressed as I mentioned it, but in terms of quality, to understand where we could test things, why we would test things, and so on. And I propose a 4-step model that I'll go breaking down. So the first one is to identify your existing test pyramid. For who's not familiar with the concept of test pyramid, you've seen one from ThoughtWorks on the side, pretty conventional one. It's a graphical way of representing the distribution in percentages of your tests, and to recommend the type of tests that you should have in certain numbers, based on whether it is value or cost. So it doesn't have to be this representation, it's just a handy one that you might find online. So first thing first is what I was mentioning before. You need to identify within your team which tests you actually have, because you'll be surprised of all the different opinions of what tests you actually have. Make sure that you identify the definitions clearly, that everybody agrees, and then double check also in the code with your team, because sometimes there's just legacy code or somebody left and used to do it in a different way. So one point is to make sure that everybody agrees on what we have, and the other one is make sure what we actually have, and see also the discrepancy between the two, which happens, unfortunately. And see how many of those you have, right? What percentages you have. Get to the point where you can draw something equivalent, and even if it doesn't have the same shape, it rarely does, right? The point is you have a clear, easy way to represent your current state of things. And we all start from somewhere. So then the second thing is you map your architecture multidimensionally. So how I mentioned before, you identify all your services, all your APIs, storage, queues, every communication mechanism, anything you might have that helps you achieve the mission of delivering a feature to your users. And then you also overlay the difference with its own infrastructure, because sometimes you don't have a one-to-one mapping with that. Not everything is serverless, not everything is microservices on Kubernetes, right? Not everything will have a one-to-one mapping with your infrastructure. And understanding the difference between that is where you also might be able to find some issues. And then what I usually do, I take a few use cases that are very important for the customer, and I walk through the architecture to see the flow of communication and how they interact. So it's more of a dynamic diagram, hence why it's multidimensional. At last, once I have all that information, I would overlay the technologies. And this is, I would say, sometimes controversial, but I do find that it's very important to solve and analyze the problem independently from the technology in which is implemented, and then look at what quirks that technology can bring. Which takes us to the next phase, which is to identify quality threats and your mitigation plan. So once you have your architecture all nice and mapped and you know your current state of tests, what you do is, as a group, you look at and you say, what do we need to test here? Is it full end-to-end, multi-services? And you go down from macro to micro and identify the category of tests that you think you should have. Perfect world we're talking about. You go down, 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 all the layers of test even within your services, and you agree with the team according to what's the mission at that point, what part, how you will implement it. So you start doing like even a mental design session to have this agreement on how you'll protect your code. And then in that way, you can start building what I've been calling again the pyramid, but your desired pyramid. Like how would the test that you would like to have, how would they look, what percentage would they have? So you have some sort of guideline, but also so you have something that you can work on a delta with, what you previously have, what you think you should have. So you can build a plan to how to implement them. And then, clearly not many teams will have the capacity to just say stop everything and do whatever's missing. So what you need to do is to find smart ways to get you to there. So my recommendation is to make sure that you build it and maintain it in a certain way. You want to make sure that A, you have certain guidelines for your team, and also this common agreement in your test pyramid desired that people will stick to, so that even if they can't change the older stuff, everything they do anew sticks to the new pattern. So first of all, from that day onwards, you don't build additional tech debt. Second thing would be prioritize very effectively. And I know this is a banality, but there's going to take probably some convincing for your product managers or whoever to give you time for your team to invest in making all these improvements. So you have to be strong about why this is useful, how is it going to make things better, and hence prioritize appropriately. And you'll see that the more benefit you get, your team is going to get quicker and you're going to get more time, but you need to own the topic at first, in my experience, clearly. So this is a little recap of the 4 steps. Identify your current state, map what you have, identify how you'd like it to be, and smartly mitigate your risks, your quality risk, until the end. Let's go to the good part. So second element for me is all the code, software, and software practices. So everything that will make you feel like your code base is a quality code base, whether it's characteristics, whether it's practices, whatever gives you at the end as an output, a code base that you're very proud of. So few ideas here. As I mentioned before, you test everything you want to work. And that means that when you build a feature, I would recommend that with the team, if you're pair programming, individually, however you're doing it, you think of how you're going to test it at the same time that you think how you're going to implement it. It's a shift in mindset if you haven't done it before, because usually you think of how you implement it, then you think, how would I match it? But if you try and solve the problem as one, the problem you have is to build the feature, and the feature doesn't exist without your test. It's going to make your end solution easier to test because you think it together. At the same way, when you build your feature, I would not recommend to add your test later. Just do it together. Whatever technique you use, I'm a big fan of TDD. I'll talk about it a little bit afterwards, but try and build it together. Whatever way is comfortable for you right now, whatever your code base allows you, like I've seen all sorts of circumstances. Try and do it as much together as you can so that there's never an after step, because the design of the two is interconnected as if it were one feature. And then test all the other aspects. If performance is important for you, put a test for it. If infrastructure is important for you, I'd be surprised if it isn't for somebody, test it. Same for security. So I'm a big, big fan of automation tests for infrastructure, for example. Controversial, but this is my experience of a good quality code base. Now, everybody has had different experiences and they have different benchmarks. But in my experience, the best code bases I have seen had roughly a ratio of 80% test code, 20% production code. That meant that roughly that is how your code base is shaped. So in these conditions, which I believe would cover the features, as I mentioned before, you have a lot of code to maintain. You still would, but you have a lot of code to maintain. And now what you have to do is to make sure that you can maintain it efficiently and that your code is easy to change and to create. So what can you do? So I'm a big, big fan of TDD, and I'm biased, but the talk is called TDD and other drugs, so I hope at least somebody is here to hear something about it. there are many definitions of TDD, and I won't go into the literature. So I'll express what comes from my experience or what I value. And it doesn't mean that other techniques don't work, but within the context of this talk, this is what I refer to as TDD. So I call TDD the technique by which I build my test code and my production code together, meaning at the same time, not the same commit, also the same commit, but I actually code them at the same time. And I am not allowed to write any production code that my test code does not ask me to have. Hence the little girl whispering the features to the other little girl. And that drives my entire design, because by the shape of my tests, I will know whether I'm designing in the right direction or whether there's another class with another responsibility. And it takes some time to design it through that, but it is achievable. And to be a little bit more precise, I follow the 3 codes of TDD from the Clean Code book. And just to make it brief, right? So the first rule will tell you that you may not write production code until you've written a failing unit test. That means don't write your test class, your let's say, class and the test before you write your test class. Not all your test class, just the existence of the class. The second one would tell you, next thing you do is you have your test, you instantiate the class you want to test, the class doesn't exist, you have a compile error, that's your red. You instantiate, you actually create the file, just create the class, that is, you run it again, doesn't fail anymore. And then what you will do, you will loop until you will have the minimum possible features until you get to the end. And this is a constant loop. And that's how you build. It's clearly not line by line, but it's close to 1 line in your test code, 1 line in your production code until you loop for the first test. And then it tends to be modify the lines and change the lines. That's why also your code tends to be 80-20. So, next thing, and I've touched on it a little bit before. Now, if test code is code, why are we not treating it the same way? Apply clean code and good design rules. Just make sure that there's no duplication. Although I believe the readability sometimes in test is more important than duplication, let's make sure that that is limited, because if you have a huge code base, readability is also being able to maintain it, right? So it's a fine balance. What we do is a science, but it's also an art. Design based on domain, all your good practices, don't throw them away just because they're tests. Your tests need to be performant. Slow test, no developer is going to run your slow test. It doesn't matter if you have the best test suite of the world. If it's slow, nobody's going to run it. I'm not going to run it. Consider, test helpers and libraries if that's your bread and butter. Make sure, of course, that your tests are independent from each other, because you want to be able to run them in isolation. All the good things. And one thing that almost nobody does is the great data setup. I don't know how many times, I have people in the room who know that, how many times I've worked on systems to set up data for tests, especially in legacy code bases. Because if you don't know the state of what you're testing, you can't test it efficiently. You would do it with your production code, do it with your test code. And again, evolve it. Don't assume that you write your test and you're done. Your production code is the test of your test code, and vice versa. Think of them as twins. You just have to use the other one to modify the other one. So they have a life that is interconnected. And then, path to production, one of my favorite things. We built all these tests, they're all nice. We have a test pyramid. We've broken it down in different categories. Make sure that you can run your categories in isolation, because you might have many, might be a big code base, whatever condition you have. Not everybody has tiny microservices. You might have, some big legacy code base, whatever situation you have. Make sure that you can split in categories your tests. So it might be that you need a feedback loop that is shorter than what you can with all your tests. Think of performance tests. Think of infrastructure tests. So you might decide that in your pipeline, so I refer to path to production as the set of steps that take you from a commit to a user using your feature in production. And hopefully that's automated, but think of it as a pipeline of sequence of events. Now, if you make sure that the appropriate test category is run at the appropriate point, let's say maybe your performance tests, you don't want to run them in dev, you'll run them in a QA test environment, right? Up to you, but make sure that you have that control, because you might want to spread it around. This is going to make your life easier. And now, we move to people. People is the most underrepresented category in software, which is surprising because human beings create software. Software is an expression of people's minds. And I tend to look at my team as an entire system. So I think of the team, I think of the code base, and I think of them together. And that's the system that I try and support, improve according to the circumstances. And it sounds very fluffy and hippie. Turns out that it has helped me out a few times in life. If you try and think of your code base and the people that work on it, all of them, not only the developers, as one system, you will look at solutions that help all. So then, if we're talking about people, what do we need to do? What do we need to address if people are not doing, testing the way that you might want it to be? You need to identify why. And more often than not, it's because of time pressures. It's because somebody told them it's not important. It is because they're not rewarded for it, because people say, I still have to do the test. Is it really going to take you another week? That kind of conversation. And yes, that kind of conversation. So then what we need to think about is, what can we do to make sure that we get to the point that people have the desire to do the thing that we would like to have as an outcome as a system? And then this book comes to help. I'm sure it wouldn't be the only one. And I see somebody in the audience that has actually done a talk on it, which means there are other people who have appreciated the book. So the book is Drive from Daniel Pink. And what he says, among many other things, is that human beings have as intrinsic three factors that help them have intrinsic motivations, things that will push them to be more performant because they're really happy about what they're doing. And these are the three elements. One is sense of purpose. So I am doing something that is meaningful, in whichever way it might be meaningful for an individual. Sense of autonomy, so a sense that I'm the master of my destiny to some extent. Micromanagement kills any form of creativity and performance. And then mastery. Mastery is the feeling of an individual that they might want to excel at something. And we know that software engineers are people in this line of business. There's a lot of overachievers. It's the kind of business that drives that kind of people. So even more, the sense of mastery is a strong leverage for us. So then, let's leverage that, right? So let's allow people to feel that they are actually building their masterpiece, but just make sure that we identify what the parameters of that masterpiece are in alignment with what, as a system, we would like the output to be. So going back to the point of before, if test code is code, and that is 80% of your code base, and that is what guarantees that the features you deliver are the ones that you expect it to do, writing test automation is actually a highly sophisticated software engineering practice. It's the pinnacle of software engineering practices. So at least it goes in among the best, the most important ones. We should make sure that we define also this element between what makes a good software engineer. And we've all come from a background where that maybe wasn't the case. And I've worked with fantastic engineers that had no clue about tests, but it's not viable for a system of quality. It might be viable for the individual, but it isn't for the system. So, what can we do as technical leaders to help? So first of all, let's communicate widely how extremely important and how extremely technically challenging it is to write test code. Let's say it wide, let's do talks, let's say it in one-to-ones. Let's make sure that in our team, this is a value, that it isn't a quality value, it's an key engineering skill value. Then, what we want to do is to also recognize every company will have their own recognition system. I won't go inside, pro and cons of recognition types. But what's important is, if somebody actually has embraced certain things that you would like to see in your system, you need to make sure that that is a positive example and that people would want to follow it. So let's try and conclude. There is no magic pill for quality. You know, a special library that you find is not going to help. Imposing TDD is not going to help, although TDD is, in my experience, the most cost-efficient way to make sure that you have that level of test coverage and quality. But, you know, everybody for their own. There is not one thing that you take a pill and you solve your quality. You're going to have to address it holistically. And in order to do that, what I would recommend is to tackle it from these three fronts. So architecture, make sure that you fully know your system and that you decide as a group and commit to what is needed, even if you can't afford it right now. Your code, treat your test code the same way as you would treat your production code. And people, don't underestimate the people problem, because if your people don't value what they're doing, they're never going to do it the way you hope they would. And then these are a few books which have been, I think, influential in this talk. I'm sure there are more. Clean Code, which has been a guide for me code-wise for a decade. In terms, if you haven't read it before, it talks about software practices, code cleanliness, and so on. Accelerate, which for me is the best delivery book I've ever read. Drive, that I just mentioned. Working Effectively with Legacy Code, which is a book that talks about on how, you know, to refactor your legacy code. And, you know, Michael Feathers will forgive me, but it can be summarized in add test before you change your legacy code in 20 different techniques. And it's an awesome book, read it. But it just goes to emphasize how incredibly important it is to write your test in whatever condition. And we all know legacy codes can be the most challenging that you'll find to do. I know I have seen a few. And then Ikigai, which is super hippie, but it helps, so it expresses the concept of finding the perfect intersection of life between areas of your life that are influential for you. And has helped me formulate this idea that we need to look at the intersection between the various things that we take care of and identify where we can act on. And then that's all. And if you have any questions, I'm here for you. Thank you. There, I see somebody there.
Thank you. More of a thought than the question really is, do you feel, as I feel at least, that if you're working in a system where the code is really well covered and you've got coverage throughout the life cycle, it's a much more enjoyable life as a developer. It's so much nicer, and you have a happier time rather than firefighting all sorts of stuff all the time.
So I like to say I like to go on holiday. And that means I like to be able to clock off and go on holiday and know that everything is safe, right? And that comes from having that guardrails, right, in your system that allow you a healthy day-to-day life. So I used to call, like, let's say, most efficient project I've been on, I used to say it was like going on rails, because the system was so strong by that point. Everybody exclusively did TDD, exclusively, from the start to the end, that your day-to-day life was just a lot more serene. So what we did most of the 8 hours, at that time, I wasn't leading team, so I was a software engineer in the team, 8-hour coding. And, sorry, I'll move over here because I can't see, the gentleman over there. What I remember is that actually the effort was put in design, and really much more fun stuff and performance and a domain, things that are a bit more fun than firefighting, for me at least, right, than firefighting, because everything was already like a well-oiled machine. And clearly we had to fix things, and not all the code was refactored and all the tests were there. But we got to the point where the sense of safety was so strong because TDD had been done for years at that point, that truly you knew that if you broke something, something would break. In my experience, the best code base, when you remove one line of code, 2 tests need to fail, and it's not a random number. One is the unit test that is checking that particular feature, and the other is in one high-level test, according to the part of systems, that says something is not working because this line of code is not here. I'm sure that in this group, you'll be able to find 3 circumstances where that doesn't work. And yes, I think you should test logging. So if you're thinking that I caught you, yes, I think you should test logging. But the idea is you don't want to duplicate your tests, but you need tests at different level. And you don't want that when you remove a line of code, 20 million tests fail. You have to do it at the right level. So yes, your life would be much better if you TDD'd all the time, in my opinion. I think just raised their hand a lot sooner.
Do you see TDD as purely in the scope of software developers, or is there scope for QA testers to get involved in TDD as well?
I see QA testers as either developers with strong quality skills, hence what I'm recommending for everybody, or some kind of leadership support. This is my view. I mean, I've worked in multiple circumstances, but I wouldn't separate the two. So in teams, I've had QAs that then coded with the team as if they were another team member. They might have had less experiences on some things, but they had more experiences in the other, like any developer will have. So in my mindset, they were a developer in the same definition that I defined there. And in other cases, they were doing less development, but they were doing more high strategy QA. And they paired with developers occasionally, so they still had that contact, but they did it at a different level. I don't know if that answered your question.
I don't think it's a right or wrong answer. I'm just curious on your opinion.
Hello.
Hi.
So I've been fortunate enough to see both sides of this particular coin. I've seen great code bases and I've seen horrendous ones. One of the real problems I've found with my own team is that there's a lack of awareness that the test-driven stuff that they should do and the lack of test-driven stuff is causing the issues they're having right now. So there's there's a feeling that it's not very good, but they don't join the two together. So they haven't worked out that it's because there's no tests or the tests aren't to the high enough quality, and because they're not directly linked and they haven't got a cause and effect that they can see. It's really hard to convince them that this behavior causes this action. Have any tips on how I can change their minds?
That's a difficult one. So I've worked as a consultant for many years, and it's not always that you get to go and do a greenfield and then you can just show how easy it is with TDD, and then you have some really old legacy code and it's like, oh my God, how are we going to do it? I think part of it is education, in the nicest of terms, right? Is making sure that that sense of value goes. Feature means test code and production code. That's it. That's your feature. There's no distinction between the two. So also addressing how potentially the existing features have not been designed to be tested, and how in that way they are tech debt to be improved. And that is a very difficult balance, because I'm sure people have put lots of effort and heart in making those the best they can. But embracing the fact that they will have a better life, you'll have a better product, they'll be better engineers. If they embrace that, is one of those things when people say it's better to know the truth than be ignorant forever, right? It's gonna hurt, but you're gonna try and improve. So unfortunately, in that case, I think the only thing I would probably urge, I don't know the individuals. In this case, I'd try to know the individuals, right? But going by default of the sense of mastery, I would try and instill in them how the new definition of mastery is that, and by that definition, the existing code needs to be evolved, and to be evolved, you need to do that. Unfortunately, I don't have a better answer. Yes, and then there's the gentleman there.
Hi, so I just had a follow-up question with what you said earlier about that you, in some case, change part of your code and then a million tests fail. Do you see that sometimes that could become like a bottleneck for your application, whereas you, in some cases, maybe have too many tests?
So let me ask you, do you measure how often your software fails in production? So for example, Andrew over there is going to do a talk on 4 key metrics tomorrow that you might find interesting. I think it's a matter of what you measure, right? If it's relevant for you, how it's going to fail in production, right? You will think that that's not a bottleneck because it's going to save you time later when you fix it and it's going to mess your 4 key metrics later on.
Okay, I'd like to ask you a question. You said that you are testing infrastructure. When you are beginning a new project, do you do at first the walking skeleton and test it, or what is your?
I don't,
process?
but then some people do. There's nothing wrong with doing that. I don't favor it because I'm a strict TDDer and my brain doesn't accept it. But I do understand that it works better for some people because it helps them work. It helps them kind of formulate the idea that they want to get to. So I have nothing against kind of experimenting. I just think it should never go to production. That's kind of my take. But I would recommend always going the other way around. But infrastructure testing is one of those fields where there's, big fights in the industry. So.
I mean, now when in the times of microservices, do you first? You said that you make a design architecture and you categorize tests for architecture, for example, and then you go down to microservices or unit tests and so.
So it depends on whether you're starting on an existing architecture. 9 times out of 10, in my experience, I've started with something that was already there, and then maybe we created a new department, let's say, new subsystem. So if you're building from scratch, then you probably have an idea, and then you'll change it 20 times from here when it's done, right? So that's normal. So then I would probably still build the minimum possible. So start with one service. I'll build the infrastructure as code to automatically generate that service, right? And then I'll think that I'll reuse it. And then maybe I'll discover there's a different one. So that's how I would go around with that.
Okay, thank you.
You're welcome. I think the gentleman over there. So many questions.
Actually, my question has already been answered.
Good. Okay. Great. You see, my talk should have been longer.
Hi. I'm going to bring this on a very practical, concrete field.
Okay.
Because it was a great talk. I agree with everything you said, but concretely, so when you start a new feature,
Yes.
from your own experience,
Yes.
what do you prefer? Do you go, how high a level do you reach with TDD? Do you start from you have a new requirement, do you start with a test and then build everything downwards? So like in a BDD fashion?
I do that.
How high do you go?
I like to do it. It depends on the system, right? If I'm only working on some subsystem that starts with the API.
Let's assume it's a web app with the front end and the back end.
I start from the UI.
Where do you work?
I start from the UI. But maybe in that case, let's say I would have either modify an existing end-to-end test. Think of kind of Selenium-based end-to-end. I can see the UI moving around test. And if one exists already, maybe I'll add something to an existing flow. If it's a new one, I'll create a new one. There, I'll probably try and be very conservative, right? Just check that I can trigger the feature. I won't go for all. And then I will keep that one as kind of a reference. So it is. It doesn't go in the conventional red-green refactor, although you can. But that is your benchmark. Your story is finished when that one goes. And then you can do more conventional unit tests with all your layers. Conventional steps, right? We all know that, there are 20 million different designs that you can use. But conventionally, you'll have a controller. You'll have your unit test for the controller. Yes, I would unit test the controllers. Controllers, your service, your mappers, your transformers, and so on and so on. And then I would have unit tests there. And then if I'm integrating with some external resource, say SQS, I'll probably have an integration test, and so on. But yes, I will start from the very far, but be conservative. Like maybe one, there is my benchmark that my feature would work, and then grow it.
So when you start with the acceptance test in a way.
In
right?
that case, yes.
Will you put this in a separate project or code base and run it against the actual code base that you are building? Or will you have it inside of somehow? Would it be a different code base or would it be same?
So default answer is
Just your personal preference. It's not.
it depends on the size of your system. So my preference is to keep everything together so I can run it all together on my machine. I think if you have a very big system and your feature is actually hopping between 20 services, then you probably keep it separate and you trigger it. In any case, you would have to trigger this in the pipeline. There's another talk in the future about just how you look at pipelines this way. But if your system is small, then I'll probably have it together. Or if what you're testing is directly in that code base. If you have many hops, then probably you would have a wider rate. Let's say you have a website with many, many features, right? Many, many features. You probably have many, many services, right? So maybe I would keep it separate. But it's something to go and consider from case to case. Often when you see a separate code base, it's because there's a separate QA team and then different people building it. And then sometimes that is a sign of some problem, but it doesn't have to be. So that's why usually I would recommend to keep it all together. So it's developers that do it together. But I do see cases where you have so many services that doesn't make any sense to put everything in one when you have 20. Unfortunately, it depends.
Thank you.
You're welcome.
Hi.
Hi.
First things first, thank you so much for the talk.
Thank you.
Quick question. So one of the items that you said to improve the code quality, right, is people, right?
Yes.
And then you mentioned that, so I was thinking like one of the things that I've seen at least in different companies is that when you work with a large code base, right, and then someone joins the company, then when trying to understand this code base, they get frustrated, right, and then that leads to lack of motivation, and then that leads to, as you mentioned before, poor written code, no, or like, and they come up with workarounds, right? I was trying to think how to apply, and you mentioned that there is a tip that is like, let them know that it's a masterpiece, no, but in a way that you would like them, right? But because sometimes it's workarounds and you are like, okay, this has nothing to do with the right solution. Any advice on how to...
So that I would call a people issue, which is definitely this is a good example of where a people issue reflects directly to the quality of your code, automatically, right? Mm-hmm. People feel uncomfortable, they don't quite know because it's a new code base. Maybe they haven't received enough support to know how that should be. Maybe, I don't know, you're missing a technical leader in the team because, I don't know, somebody win the lottery is not in the team anymore, you know, that kind of thing. So there's potentially some lack of leadership and probably some lack of onboarding, right? If all of that doesn't work, there's probably, sorry, I apologize in advance, there's pair programming. I don't all leave the room, but I still enjoy it very much. I do think it works. I do believe it works better than PRs. Sometimes you don't have any other option. PRs still do the job. But in a case where somebody, either for whatever good intention, right? So everybody, when they start a job, they might feel under pressure. They want to perform. So or maybe they haven't seen anything different before. So they'll just knock together what they used to, right? It's for the team, for the system to support them into doing it the way that they would like it to be. This is another thing, right? Let's solve people issues. Let's look at the high consequences of people issues on software.
Thank you.
We have 2 minutes and then we're going to be kicked out because there's another speaker.
So my question would be like two parts. One would be like to gentlemen here who ask how to test. I think it's worth to read the book. I think it's by Ken Beck. He showed in the book how he wrote in TDD the whole JUnit framework, like starting actually from the very kind of like the white, mocking a lot of things, and then he just go down, and at the end he's got the working JUnit framework, yes. And the second question is, yes, like I'm really into testing, yes. I believe I have everything what you just say here, yes, but we are working with other people, other stakeholders, we have team members, we have, I don't know, management, we have kind of like other teams. We come into our new project, and how to actually, the best, in your opinion, is advocate for the things we are talking here.
So very difficult question, because there are 20 answers and it depends on the actual. So if I were sitting with you in your team, I would have better answers, but I'll give you a few and maybe you'll find something that fits there. So on the first point you made, I do believe that people, very valid people, have done TDD in slightly different ways. I don't think the way I do it, in any case I copied from clean code, is necessarily the best way, but it has always worked for me. So, that's one point. The other point is, that's why this is a holistic approach. So in some of this talk, it was also an appeal, to technical leaders to say, make sure that you stand your ground with this kind of thing, and that for the people in your team, you educate them that this is something you value, this is going to be in your performance review, whatever. Like the same as other features. So I remember I used to work in a company that used to give bonuses, and doing some, improvement feature that was really fancy and showed engineering excellence would grant people, a couple of salaries. And that was utterly useless because it actually had no business value, right? Let's try and align performance. I don't particularly believe in bonuses, but whatever reward system we have to something that has business value for the system. That's one thing. In terms of product owners and so on, it needs to be, so there are two approaches, and probably a mixture needs to be considered. One is to explain and over-explain and continue to explain the impact of making those changes, and how how you think it is going to improve the overall velocity of the team, because better quality code is going to just make you quicker, right? So, but it's an investment, and there's all that line of convincing, which is absolutely true, but it takes usually quite a few iterations, and usually you need, a quick win and start showing some results and how things make it quicker. Or maybe if you have a new project coming in, you have an opportunity for a little piece of green field where you can see how that goes quicker. That's the kind of thing. And the other one is, sometimes we need to stand our ground. So I have literally refused to write some code without tests once, not even too far ago. I've literally refused, meaning that all my leadership asked me to do it, and I didn't do it. Why? Because, unfortunately, we are the only people who actually write the code and know what is a risk and what isn't. And when you go to a doctor, do you question the diagnosis? This is my question, right? Like, there are things that we can not over-engineer, and you don't need that new library, and you don't need that fancy thing, and you don't need that, but you do need your tests. Like, there are some things where, I need to upgrade packages if there's a reason for security. Fair, that's fair. You don't need to rewrite all of it because you want it to be prettier, right? Or because this new library has come in and that's cooler and all your friends are using it. No, you don't need that. But you need your tests. There are some things that you need to stand your ground and say, I'm not doing my job if you don't let me do this. You're literally having an impact on the key characteristics of my job. And the problem is, we're not associating test code with the key characteristics of our job. I don't ask permission to write test code. Never have. Don't know if that resonates in any way. I don't say, there's a test card, I have to do the tests. I just do it. Sorry. I wish I could help you more.
I know.